Hi everyone, in this video we are going to describe how to name covalent compounds known as molecular compounds, describe how to name ionic compounds, and describe how to name compounds that have polyatomic ions present. So let's start our discussion with describing how to name covalent compounds. Now remember, I'm trying to get this point across. Whenever you hear the term molecular or molecular compound or molecule, it is a covalent compound. So let's take a look at a few. So our first task is going to be recognizing whether or not we have a molecule, a covalently bonded compound. So these first examples here, now please be mindful the twos here are supposed to be subscripts. The software here just didn't allow me to print it in that fashion. So here we have O2, Br2, and NO2. We have to recognize that these are in fact not compounds. They are diatomic elements. All right, because oxygen, we have two oxygens. I don't like that yellow pen. We have two oxygens. We have two bromines, two nitrogens. They are not compounds. To be a compound, you have to have two or more different elements bound together. All right, so here we have hydrogen and chlorine, hydrogen and bromine, carbon and oxygen, carbon and fluorine. And to become a covalently bound compound, it has to be nonmetals bound to nonmetals. And allow me to highlight for you to the regions of the periodic table that denote nonmetals, reactive nonmetals. Hydrogen, yes. Carbon, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, selenium, sulfur, phosphorus. All reactive nonmetals. So these will have covalent bonds in them, and we need to name them accordingly. Let's look at the next slide to start that process. So we have to become familiar with these things called prefixes. So these are numerical prefixes for binary compounds, which are molecules. Now prefixes are additives to a word that go before the word to modify it. And these indicate numbers. Now binary, in fact, has its own prefix, bi meaning two, binary covalent compounds. So they're going to be compounds that have two different types of elements, no more. So for mono means one, di means two, tri means three, tetra, penta, hexa, hepta, octa, nona, and deca. Chances are we'll only get into these first five, but be mindful of the others. Now keep those prefixes in mind as we look at this slide. I stole this from this website down below here, and it identifies the rules for naming binary covalent compounds as well as ionic compounds. We'll do this part later, so let's slide in and look at this. Now I recommend strongly that you pause this video at this moment and write these rules down. In fact, consider writing them in as a flow map, which has the steps written in this fashion. Brain science suggests that it is easier to remember if you do that. So these rules are like this. You write the name of the first element down. If the symbol is followed by a subscript of two or more, not one, you use the appropriate prefix to denote the number. So you do not use mono, but you can use di, tri, and so forth. Next, you look at the second element and write the root for the name of that element and end it in IDE. That's a suffix. So oxygen would become oxide. And then you use the appropriate prefix to denote the number. Now I am going to change this briefly, so change your notes if you need to. I would not use it for one either. So a di, tri, or so forth. Now sometimes you will see mono for this second one, but don't let that throw you. So here are some examples down below. We have an example of carbon dioxide. We have an example of P. Now that's supposed to be a lowercase l. PCl3 is phosphorus trichloride. And As2P is diarsenic pentoxide. Let's try some for ourselves. Alright, so here they are again, but this time I did write them because I do like the subscript being where it belongs. Remember, O2, Br2, and NO2 are all diatomic elements. They retain their name. That's oxygen, bromine, nitrogen. They do have covalent bonds, so they are still called molecules. Now let's take a look at HCl. HCl is also known as, grab a pen, hydrogen. We do not need a prefix because there's only one of them, and this is chloride. Hydrogen chloride. There is only one of them, so I do not need a prefix. The next one is, again, hydrogen. And no subscript for bromine, indicating there's only one of them. That's hydrogen bromide. B-R-O-M-I-D-E. This next one, we have one carbon, two oxygens. So this is carbon di for two, oxide. And lastly on this page we have one carbon, four fluorines. That one is carbon. And the prefix for four again is, where are my prefixes? Right here. Tetra. You see? 4 tetra. Let's get that off the screen. So this is carbon. Tetra fluoride. Okay, that's how to do those. But let's take a look at one that has a prefix for the first element. Alright, so here is a compound. The formula is written as Cl2O, and this picture here is not only a dot diagram, but it's also a structural formula. It's showing this dash as a shared pair of electrons, showing you now also the unshared electrons as just dots. And again, it's CCl2. So there are two chlorines. The prefix for 2 is di, and it's chlorine. And how many oxygens? Only one. Dichlorine oxide. So next, we are going to describe how to name ionic compounds. To remind you, an ionic compound is when a metal will bond with a non-metal. And this happens because the metal tends to form what we call, grab a pen, cation, and the non-metal becomes an anion, which furthermore means that the cation, the metal, will become a positively charged ion, while the non-metal will become a negatively charged ion. Now this system in a way is simpler, but in other ways it's a little bit more complex. So let's dive in. So here once again is that slide that I showed earlier, showing the rules for naming compounds, focusing now on the ionic compounds. I suggest once again strongly you stop and write notes on this, but I want to modify it just briefly. I want to take out that for right now and that for right now, and go ahead, take notes on it now. So now let's go over it. Write the name of the cation, which is the metal. So you write that first. Next, you write the name of the anion, and this doesn't say it, but add this. You put the suffix IDE at the end, just as it was done for naming covalent compounds. Next, if the metal ion can have more than one charge, place a Roman numeral after its name to denote the charge. This is extremely important. Now here are some examples. Only the first one really applies to us at this moment. Let's take a look at it. So this is sodium bromide, and one thing to note here is we do not need the prefixes as noted in the for the covalent compound. So we don't need mono, di, tri, or otherwise. On the next slide, I'll show you why. So here we have two examples. This first one has sodium and oxygen. This next one has magnesium and fluorine. So how do we name these? Okay, well, as the instruction said, this is simply called sodium oxide. Now, there are two sodiums here. Why don't I have to say disodium? And it comes from this. When we first put together the formula, we have to denote the ions that they like to become. Sodium tends to become a positive 1 ion, while oxygen becomes a 2 minus. Well, if that's the case, we're locked in. It has to be two sodiums no matter what. It has to be one oxygen no matter what. So there is absolutely no need to put in the prefix, when in fact we could figure it out ourselves by rolling back and looking at the oxidation numbers. For that matter, this next one is called magnesium fluoride. And if we were to look at the oxidation numbers, the ions they like to become, magnesium likes to become a 2 plus, and fluorine likes to become a negative 1. And that helps us understand the formula. So once again, we do not need the prefixes. Alright, so this is the area where it becomes a little bit complicated. Here we have two different ionic compounds with iron and oxygen. If you see here, iron would tend to become either a +2 or +3 ion, so we have to account for both. We have to somehow tell the reader of your formula, of the name of your compound, what the formula really is. So in this first example, we have FeO. So what do we call this? Well, this one is called iron 2 oxide. The reason why I know that is because we have a 1-to-1 ratio of iron to oxygen. And if I inspect oxygen, I would know that oxygen gets a -2 charge here. So to be a 1-to-1 ratio, I would have to have a 2 plus charge here. So I am using the +2 version of iron. Now let's take a look at this next one. This one is iron 3 oxide. Looking more deeply at that, again, oxygen likes to become a -2, but in this case, iron is taking on the 3 plus. So that 3 plus has to be identified with this Roman numeral. So to the last goal, describe how to name compounds that have polyatomic ions. For this, we have to use the rules for naming ionic compounds, but do not alter the name if a polyatomic ion is present. Here are a few examples. So now I'm running out of time. We only have 15 minutes for each of these videos. One thing you must note whenever you are given a formula is that if you have more than 2 elements, you have to be suspicious of a polyatomic ion, that one is present. And then you always inspect this table to see if that is in fact true. So if we have NH4, which is ammonium and Cl together, it is called ammonium chloride. If you have NH4 together with oxygen, it's ammonium oxide. Because we're running out of time, I'm just going to remove these blinders so that you can inspect for yourself.